Hello again. We're going to continue with some more examples of the intricacies of functions in C++. In our first exercise, we're going to sort of demonstrate what the term pass by value means with this example. So putting a notebook together, here's what we're going to do. Space it out. Okay. Exercise 1. Write a program with a function called 2times. So we'll keep that in mind. It's called 2times. That takes an integer parameter value, int my number, doubles it, then prints that value. So in that whole description, at no point did it say that 2times returns anything. And so since it doesn't, I know this is going to be a void function. In another cell, there's some other stuff, but I'll worry about that later. I need to take this value, double it, and print it. Okay, so my number times equals 2, and print it. My okay. In another cell, call 2times given a value, and then print the integer again. So let's get an integer value equals, say, 10. 2times 10, and then we'll print the value. Now, what do we notice? We have 10, 2 times 10 is 20, no surprise. And what got printed out? Well, we called 2times first, so we went over to here. My number is 10. It got doubled from 10 to 20, and we printed out 20. It all makes sense. When we come back down here, we see that even though my number got doubled to 2, the value is still 10. And in fact, this happens regardless of the name that you give. So if I go over here and I change all these to value, there's no difference. And what this means is that 2times is what we call a pass by value function. It is a function where when you give it a number, sorry, I said value, but there we go. Doesn't matter if it's 10, you can change the number if you feel like it, 20, so on. When we call this function and give it the value, what we're giving it is not a reference to the same variable. We are giving it a copy of the number that's here. So if I say I want to double 20 and turn it into 40, well, this 20, a copy of it is sent to this function, but the original 20 value still stays where it is. It is not adjusted. And so even though we doubled 20 to 40 over here, that's not affecting this variable. It remains as 20, and so I can print it out and it's still 20 again. My value is still 20. So this is a print by value functions, and sometimes that's okay. Maybe it's you just want to modify the copy of your value, and you don't want any of these changes to persist. But sometimes you write a function and you want it to actually modify these values, so you need to do something different for that. Okay, for our second exercise, let's take a look at memory in C++. This is one of the many things that makes it somewhat distinguished from something like Python that does a lot of your memory management for you. Let's start by taking a look at how the computer manages some of the basic kinds of memory, for instance, from our variables. Let's call this exercise 2. And let's make some common variable types, like size of an integer. So we can see size of immediately changes color, and that's because it is a special keyword in C++. That means, given what's in the parentheses, determine how many bytes that takes up in the computer. We can see here that a integer takes up 4 bytes. The size of a character is a single byte. The size of a double is 8 bytes. The size of a float is only 4 bytes. So you can see here that double has more precision than float does, or at least it should. Now, those are some common variables, and you can try some more if you like to, but let's make some variables and print their addresses. So if you check out your format specifier specifics, you can figure out what that is, but I'll just show you in case you didn't have the chance to look it up. So we'll have, let's just do characters. So we'll do letter 1 is A, and letter 2 is B. And we saw from before that the size of a character is 1 byte. When we print out their addresses, so the format specifier for an address is %p. We'll do 2 addresses. And now to get to the address of a variable, so we want the address of letter 1 and we want the address of letter 2. And so an easy way to remember it is address is like ampersand, so ampersand goes in front. Missed a closing parentheses. There we go. And what do we notice? There's a really long sequence of letters and numbers, but at the very end, we got 0 to 8, 0 to 9, because those are the spaces in memory that are storing each one single character, one single byte apart. Now let's say I do it with integers instead. Int number 1 is 1, int number 2 is 2, and then I'll print out the addresses of number 1 and number 2. Okay, so something kind of weird is going on here, and this is something that we're not really necessarily going to cover too much in this course, but it is something you will eventually need to know, which is that each of these symbols here, whether it's a number or a letter, actually does refer to a value. F in this case happens to actually represent 15. And the reason that I know this is because this is hexadecimal, which means that is a base 16 form of mathematics. And to count in base 16, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then instead of saying 10, we say A, because we actually don't loop over to the next digit until we go through A, which is 10, B, which is 11, C, which is 12. And you can see here the C represents actually 12. D for 13. D is 13, E is 14, F is 15, and then when we hit 16, because hexadecimal is base 16, we actually go to the next number over. And so we go from C to D, E, F, and then we don't have G, we just go to the next number over. And that's 4 bytes, which is the size of our integer. And we go from 2C to 30. We increment the left digit, and the next one goes over. It's okay if you don't really understand the mathematics behind how these symbols are operating, but what you do want to look at is that each of these variables actually is right next to each other in the computer. Notably, the integer number 1 actually looks like it is only 4 bytes away from the last character we had. So we had 28, 29, then 2A, 2B, 2C. So there's sort of 4 byte spaces that looks like it's using in the computer. And that's pretty much it for this exercise. So my recommendation is that if you really want to get more comfortable with this kind of mathematics, try doing some examples of this. Make some other variables of different kinds, maybe some doubles, maybe some floats. Make as many variables as you want and try printing out all their addresses. And you can get a bit of an understanding of exactly what the computer is doing when it comes to assigning addresses for all of these values in memory. Try it out, and then on to the next one. Okay, number 3. So in our first exercise, we had a pass-by value function. It doubled a number, but it didn't actually permanently change our variable. Here we want to do that. So let's make a new notebook. This is exercise 3. Okay. Write a program that gets an integer from the user, then write a pass-by value function that takes the integer as a parameter, prints its address, squares the integer, and returns it, and then do it again with a pass-by reference function. Okay, so first things first, if we want to get an integer from the user, we need iostream. We need to prompt the user, say give us a number, and we need to store it in a variable. Input, put their input into the variable. So now let's say if they ask for 10. Now we want to write a pass-by value function. It does say what we're going to do. We're going to return an integer. So the type is integer. This looks like it's going to square stuff, so we'll call it sqr. And the parameter is a single number, so we'll say number. Okay, we need to print out the address, %p, and to be specific, we'll say pass by value address, and that's the address of my number. We're going to square the integer, times equals 2, and we're going to return the number. Okay. Now we'll do the same thing again for a pass by reference function. The only difference in how we write it is that we just add an asterisk. Or sorry, we add a, not an asterisk, an ampersand here. Pass by reference address, same thing, same thing, same thing. Okay. So our input now is 10. If I do my, and let's give these different names. So this is going to be square value, and this will be square reference. Okay, so square value of my input, the pass by reference address is this, and when I, oh sorry, it's supposed to square it, not multiply it by 2, times equals the number itself. Seems like I'm always putting 2 in places when it should be something different. Okay. All right, so yeah, 100 squared is, 10 squared is 100, which sounds about right. The value of my input remains 10. I haven't changed it. Now let's try the other function, square reference input. Actually, before I even do that, let's take a note of what my input's address is. Printf address of the input. What's that? Oh, sorry, yeah, the address of the input. There we go. Okay, the reason I want to do that is because now I want to try my square reference function, given the input. And here's some things to notice. The square value, when it gave us the address, it gave us some new address that we hadn't seen. This address is the exact same as this one. Because it is a pass by reference function, we are actually giving it the address of the variable in memory. So now that it has squared my input is now 100. It has been permanently changed. And so this example really demonstrates the difference between these two different kinds of functions. This pass by value function, when it squares the value, it's been squared only in the context of the function itself. And so I can call square value a whole bunch of times. Square value, square value, square value. 100 times 100 is always 10,000. But my input is just going to stay as 100 until I call my square reference function. My square pass by reference function will take the number and will keep making it bigger and bigger and bigger until it literally runs out of space. The computer can't actually fit a number in anymore, which is why you get this wacky thing here, because literally the computer cannot store an integer higher than that. So that, I think, is perhaps a good way to look at the difference between these two different kinds of functions and why it can be very important not to forget that a single symbol is the difference between a permanent modification to a variable and simply not making any changes. Okay, on to the final exercise. Okay, so I'm going to talk a bit about scope. And scope refers to basically the region of code through which a variable is defined. And that can vary quite a bit depending on how you write your program. Okay, so we're going to start out by needing to write a variable, because it says we need to write a function that has a parameter with the same name as a global variable from another cell. So let's say I have my variable, say double pi is 2.14, right? And now we're going to write a function that says, will be a void function called print pi. And it will take double pi, and we're going to do bad math and say that pi is now 3. Because people have actually proposed doing this. This is a true story. Obviously, this doesn't make any sense, but people have tried. And then we're going to print out pi is now percent f pi. Okay. Now, in a subsequent cell, call a function, then print a variable again. So print pi of let's say we give it the value pi. So this pi is now 3. And if I print out pi, wait now, it's 3.14, but I seem to have changed it, right? Well, you might say that maybe this is because this is clearly a pass by value function, right? I passed it the value of pi, but I didn't pass it a copy of pi. And so if I put in the ampersand here, what do we notice? Well, hold on, let me, sorry, let me rerun this again. Now it has actually permanently made the change. But here's another thing to note. That's perhaps because we're passing it this variable. What if we don't pass it this variable? What if we were to pass it something else? Let's say we do the following. So we got pi is 3.14. This takes pi as a reference and then makes it 3 and then prints something out. What if I do this? Int new pi is 3.1415, or sorry, the double new pi is 3.1415, and we'll pass new pi. Take a look at what's happening here. We have one variable called pi, which is 3.14. Our function takes also a double, but here it's taking something by a reference, which means it should permanently change it, like we kind of saw just a second ago. We'll do our bad math and turn pi into 3 and print out our message. And we can see it seems like everything is going okay. But when I try to print pi out again, it still says it's 3.14. And the reason for that is just because this says the same name as this variable does not mean the two are connected. And in fact, they are not. Specifically, the variable that this is referencing is actually our new pi down here. It's the one that we actually passed to the program. Which means that even though we made a permanent modification in here, it's not to this version of pi, it's to the new one, which is 3. So when you have duplicate names of variables, things can sometimes get very confusing. This is why it's important to try not to have duplicate variable names if you can help it. And if you do, make it very, very clear which one is which. All right, that's it for this video. Can't wait to see you in the next one. Take care.